Welcome to this Maths Made Easy video on proportion. And to start with, let's take a look at direct proportion here. So we say if two variables are directly proportional, then as one of the variables increases, the other also increases by the same scale factor and at the same rate. So if we've got two variables, say x and y here, then we could say y is directly proportional to x. And the way we represent that is using this special symbol here. Okay, this special symbol here represents proportional or proportionality. So in this case, if we want to say y is directly proportional to x, then we write y is directly proportional to x. Okay, so this represents this symbol here. So if we've got the variable y, and we have the variable x, then y is directly proportional to x. That's what this represents here. However, we can also represent it in this form here. Y is equal to k times x. So this is equivalent. So these are equivalent here. And k represents the constant of proportionality. Okay, so k is the constant of proportionality. So we just write that down here. And that's what k represents there. And like we can see here from this table, we can have a few other representations here for direct proportion. So y is directly proportional to x squared here. So if we have y, and we're saying this is directly proportional to x squared, then we represent it in a similar form here, obviously just replacing the x with x squared. And again, we could write that as y equals kx squared. And again, y being directly proportional to x cubed, we can represent it in almost a very similar fashion here, and again here using k. And finally, y could also be directly proportional to the square root of x. And again, we just use the same notation there. Okay, so that gives us everything we need to be aware of for direct proportion. Moving on now to inverse proportion. So if two variables are inversely proportional, then we say as one of the variables increases, the other decreases by the same scale factor. And if we're given two variables here, say x and y again, then we can see clearly from this table a few examples. And notice we use the exact same notation as we did for direct proportion here, with this symbol and also k, where we remember k represents the constant of proportionality. So here, what we're saying is y is inversely proportional to x here. So this is our first example. So when we have y and x, here we're saying they are inversely proportional, then we write that in this form here, or as y equals k over x. We could also say here that y is directly proportional to 1 over x in this case. So that's just another way we can actually explain this idea here. Okay, but notice again, we can also just use k here rather than using this symbol. And like we can see, we've got a few examples here. So if y is inversely proportional to x, then we could write that as y equals k over x, or we could use this symbol here. And again, for x squared here, we could write that as y is equal to k over x squared. And again, if y is inversely proportional to x cubed here, then we just write that as y equals k over x cubed. And finally, if y is inversely proportional to the square root of x, then we could just write that as y equals k over the square root of x there. So that gives us everything we need for inverse proportion. And finally, moving on to proportionality graphs. We have 4 examples here that we need to be familiar with, but we also need to be familiar with the general shape of these graphs. To start with, we have 2 examples here for direct proportion represented by the blue graphs, and we have 2 examples of inverse proportion represented by the red graphs. Now in the case of these 2 blue graphs here, which represent direct proportion, we start off with y being proportional to x. And we notice this is of the form y equals kx. So in this case, this is just a linear equation. And as this is a linear equation here, when we plot this, we simply obtain a straight line here. And this follows the idea that we understand for direct proportion. As one of the variables increases, so as x increases here, notice the y variable also increases here. Okay? And we can see the same idea here when y is proportional to x squared. Notice as x increases here, y also increases. And again, notice this is of the form y equals kx squared here. and this is a quadratic, and we have that quadratic shape here for positive x values. Now moving on to inverse proportion, here we have two examples. We have the example here where y is inversely proportional to x cubed, so we represent that as y equals k over x cubed. And we can notice here now, for example, as x increases, our y value decreases. Okay, and we can see that clearly from the shape of this curve. This idea is also represented in our second example here, where y is inversely proportional to the square root of x. We represent this in the form y equals k over the square root of x, and we can see clearly as x increases, our y value decreases here. Okay, so that concludes everything we need to be familiar with for proportionality graphs. And that concludes this Maths Made Easy video on proportion.